when you are setting a condition, you can simply break it up. Sum of clockwise moment is equal to sum of anticlockwise moments.
Thank you.
Okay, someone go through question 2. Read for us. Yes.
John, Joyce, and Janet are seated on a seesaw as shown below. Where should John, whose mass is 60 kilograms, sit so that the seesaw is balanced horizontally if the masses of Joyce and Janet are 50 kilograms and 20 kilograms respectively?
Okay. Janet, what is the weight of Janet?
20 kilograms.
Okay, I have converted to newtons, multiplying each of them by 10. But I don't write the kilograms, the mass, but I write the weight. Then we are finding John's mass.
600 newtons.
600 newtons. Is who? That is 600 newtons for
John.
John is here. Janet. And the first one is
Joyce is 500. Joyce is 500.
Joyce. 500. Okay, so what are we finding? That is D. D.
Where should John be?
Where should John sit? Okay, so this is the diagram. It's 1 meter. This is 1 meter. And then Janet is 1 meter from the pivot. Joyce is 2 meters from the pivot. John is at D from the pivot. So this diagram now summarizes the information. We can rewrite the same condition that this center will get, but at equilibrium.
Monitor.
What did it say?
Taking moment.
Next moment at D.
The sum of the what?
The sum of the anticlockwise moment
is equal to the sum of clockwise moments.
Okay, so the sum of the anticlockwise moments is equal to the sum of the clockwise moments. Okay? Okay, I have written in full. So can we find these two are the anticlockwise moments. This one and this one. This is almost the same as the previous example. There's no difference. So we're just going to multiply 500. Can you tell me what to do now?
500 times 2.
500 times 2.
In brackets,
200 times
200 times 1.
200 times 1
equals to
600
times D.
600 times D. So this one you get 1,000.
200 plus 600 equals 70.
So this is 1,200.
1,200 is equal to
When you
600.
divide this by 600, D is equal to
2. D is equal to
D is equal to 2 meters. Okay. So John has to sit 2 meters to be 2 meters away from the pivot in order to balance the other two people, Joyce and Janet. Is that clear?
Yes.
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 And opposite side. It's on the opposite side of the pivot and it's balancing these two on this side. So can we go to the next example?
Is it a must to change kilograms to Newton?
Yes, you need to, because you have to go by the principle of moments. So you should not work in kilograms. You should convert that to newtons.
But it gives the same answer.
Yes, they do give the same answer, but there is a principle we are talking about. The principle says it's the principle of moments, and what's the moment? Forces, not masses. Okay. Yeah. Please, shortcuts will kill us. It is forces, not masses. So first come back, go back. Is that okay?
Yes.
Let us not take shortcuts because we are going. Because when you're talking about the modifying those principles, weight is a vector quantity. You need, when you are talking about the moment, or you're measuring moment, you're finding a force, multiplying the force by the what? By distance. Okay. So this force cannot be given in terms of mass. It has to be in terms of the weight. Okay. Next example. Example 3. Example 3. So this answer is going to take you through example 3. What is my solution? Reactions supported calculations is very important deal with you.
Okay, thank you, previous teachers who have taken us through example 1 and example 2. So in example 3, we are going to, there was a question from Aine in the chat. She was asking, is it that the words draw the diagrams for you in the questions? They can set a question without a diagram and they want to sketch it. And the very first example, Mr. Senjobe worked out, it didn't have a diagram. So you needed to first work out that to draw the diagram. So you need to learn how to sketch the diagrams, and they are not difficult at all. Okay, let's go through example 3. The previous examples have been having a knife edges. Now in this one, the metal is supported by a string. Okay, someone take us through example 3. May you read the question?
A bar shown below is in equilibrium.
Who's reading?
Find the force F.
Okay.
Okay, so they have given us 80 newtons, and then we have a force P, a force F. Then they have given us distances. This is 40 centimeters, and we have this distance as
70 centimeters.
70 centimeters. Thank you so much. So the question they want us to find force F. Calculations are backed up by the principles and definitions. So we want to find out and principles have conditions. So we want to find F, and we are going to use a principle. and that is the principle of moments. And that principle of moments has a condition. One of the conditions which we have been setting, which says the sum of the clockwise moments is equal to the sum of the anticlockwise moments above a point. And the point we are using this convenient point, which is the point or the turning point, the pivot, okay? So this time around, we are using a string, not a knife edge. Okay? So we are going to apply moments about this point here. That's where we are going to apply moments from, okay? And the condition we are going to use is very simple. It states a sum of clockwise
Moments.
sum of clockwise moments
About a point.
equal to sum of anticlockwise. It's very okay to write this statement. Someone was asking about these statements. It can carry a mark on a good day because you are using that condition, okay? It's very fine to use. So we want to identify. We know that we're talking about sum of clockwise moments. We need to identify which one is a clockwise. Some of the clockwise moments are equal to. Okay? So we are using this statement, which we pick from the condition. But we know that from the principle, we specify that they are about a point, okay? And that point is the pivot here. Okay, so now we want to identify which one is the clockwise moment about this point in this case. Can someone share with us?
F.
F is the clockwise. Thank you so much. So this one is the clockwise moment. Then the anticlockwise moment in this case.
80 times 30.
80 is the anti-clockwise moment. Okay, so those are the only forces we have that cause a clockwise turn and an anti-clockwise turn. Okay, then we are going to find the distances because we need to identify the distances, the perpendicular distance from the line of action of the force to the turning point. So that means a moment is simply equal to force times distance. So clockwise moment we have the force times what is the perpendicular distance from the line of action of this force to the turning point?
40.
Wonderful. 40, okay. I'm not converting to centimeters for the reason you gave in the previous examples, because the units will cancel out. When units are canceling out, you may not have to convert because you get a stem. All right, now we want to get the anticlockwise force is 80. Now we want to get the perpendicular distance from the line of action of the 80 Newton force to the turning point. Who can tell us the distance?
30 centimeters, which is good by getting 20 minus 40.
Wonderful. So they gave you this 70, but you needed to identify that from the line of action of this force to the turning point, which is 70 minus 40, giving us 30. That is very wonderful. You need always to identify these distances very well. So times 30. So we get times 30. So this centimeter cancels out, and then centimeter cancels out. That's why we are not converting, okay? So this gives us 40F is equal to 80 times 30, you get
2,400.
Okay, thank you so much. Divide by 40, divide by 40. So how
60 Newton.
60 Newtons.
60 Newtons.
Wonderful. Thank you for being a very active class. Okay, are we through with this working?
Yes.
Teacher, are you supposed to put the units like the way they have set it in the question, like if the weight is in kilograms, you have to change the newtons to kilograms, or you can just leave it as newtons?
Forces are measured in newtons. mass is measured in kilograms, okay? And here we are dealing with forces. So this thing Newton's answer. We don't cause these moments. A moment is force times distance. So we deal with forces. When they bring in masses, that's why Mr. Gonza converted the previous question, convert the kilograms to newtons, because we are dealing with forces. When they give you a mass, it's better you convert to a kilogram.
Thank you.
Teacher, I have a question.
Teacher.
Okay. Yes.
I have a question.
So to conclude the previous question, the question can ask for a mass given a question like this. So when you get the 60 newtons, then you use F is equal to mg to convert it back to kilograms by dividing by 10. So in case they gave you this and the question is find a mass that can be used to balance this body, then you work out and then you end up by converting the force you've gotten back to kilograms. What was that other question?
My question was, sorry to take you back, but the last example, the example that was before this one that we're doing, I didn't get why the units like 50 kilograms and 20 kilograms, why they changed them into 500 and 200. My network wasn't really good, and I wanted to know.
So the mass given was the mass was 50 kilograms, right?
Yeah.
So how do you convert this to newtons?
It's that times gravity force, which is 50 times 10, right?
So together weight is, we use mg, which is this, times 10, together 500 newtons, okay? So this are converted because the principle deals with forces, not masses. So it's better is to work within the units of the principle, because we talk about moments, and a moment over force is equal to force times distance. So it's better you work with forces, you convert the given masses to forces. Is it okay now?
Yes, teacher.
Okay.
Excuse me, teacher.
Yes.
How come we are not using the other condition?
I want to use that other condition. I want to pose another question in this very question.
Teacher.
Let me do that and then I'll get to the other questions. What is the force that we find in stretched strings? Can someone remind us that force?
Tension force.
Tension force.
The type of force we find in stretched strings.
Tension
force, okay? So this force, this string is stretched, so it has a tension force within it. Let's call it T. Assuming there was, suppose another question there saying find the tension in the string. Just include it there in your notes. Find the tension in the string. I just want us to quickly do that. So we can use the other condition like someone asked. Find the tension in a string. Are we good to go? Should we start working out?
Yes.
Yes.
Yeah.
Okay, we want to get our tension in a string. So can someone set for us the other condition?
Sure, our condition is
The sum of forces acting in one direction is equal to the sum of forces acting in the opposite direction.
Wonderful. So here we have only two directions, the upward and the downward direction. So sum of forces acting in one direction, sum of forces in one direction is equal to sum of forces in the opposite direction. In the opposite direction. We also want to use this. So now we have one direction, which is the upward direction, which is T, okay? And is the only force that is in that direction, okay? It's equal to sum of the forces in the opposite direction. How many forces do you have in the opposite direction? When you look at that diagram.
2.
Which?
80 newtons and 60 newtons.
Wonderful. So we have 80 newtons plus 6 newtons. So that gives us our tension force as.
But class has ended. Class has ended.
140 newtons. Okay, so that's how we can apply the second condition, and we are going to find it in several examples in our notes. Our time is it's already
So where
1.
did the 60 come from?
60 in the previous working was what?
F.
60 in the previous working was?
F was
F.
F. The 60
So F is one.
is the clockwise force.
So this is the clockwise force. So one T is one in one direction, the other forces in the opposite direction are 80 and F. So Mr. Sanju has put this working with the F because it's T is equal to 80 plus F, and our F is what we got as 60 in the previous working. Any other question before we close the lesson?
How did the sum of forces in one direction is equal to the sum of forces in the opposite direction turning 2t is equal to 80 plus 60? Why do we add? Are we supposed to say 80 is equal to 60?
80 is a downward force.
Do you want teachers to start singing? You think we cannot sing?
But teacher, that's a boy, not a
Yes.
teacher, boy is not a lesson.
For
But seriously, we have said the sum of forces acting in one direction. Not listening.
Please mute your microphone.
Please help us mute all the girls. We have forces acting downwards. How many forces were there? Can you look at the arrows pointing down, girls? Which arrows have forces pointing down? 80 and F.
It's a boy.
Yes.
It's a boy.
Yes.
It's a boy. It's a
Whoever
boy.
has that, brother.
It's a
But
boy.
that is in
It's
this
a man.
So we have John Black in our class.
and in discipline at home. These are your relatives, people.
We got a man in the class. Man in the class.
Okay, have a nice day.
Teacher.
Teacher.